Tables number 1 is a non-calculator question, and in part A, we're asked to find f prime of 4. So this is where we are going to use the average rate of change to approximate that instantaneous rate of change. The first thing we need to do is locate where 4 is in our table. So the 4 is going to lie in between 3 and 5. On this area is where we're going to do our average rate of change. So we just show the f of b minus f of a over b minus a. What I have boxed here is the mandatory part of the problem. It's going to earn you a point. You don't have to do any calculations, so literally what you see in this box is all you need to write, and you earn that first point. In part B, I'm asked to evaluate this integral, and I'm going to use the fundamental theorem of calculus. It's asking me to show the work that leads to my answer. There are different ways to do this. I'm going to show you one way, and then I'll show you an alternate way, and you do whichever works best for you. I split it up initially into two separate integrals across a subtraction or an addition sign. You're allowed to do that. This first integral is just the integral of a constant, so the 13 minus 2 times that value is how I evaluate that first integral. In the second integral, I know that the antiderivative of f prime is just f. So my antiderivative of 5f prime is this 5f of x. My limits move to the end, and now I'm ready to plug them in, which I've done in the next step. This first part of the problem ends up equaling 33, and then plug in the 13, plug in the 2. Evidence of using that fundamental theorem is going to earn you 1 point. Then as I evaluate, when I plug the f of 13 in, I look and I pull that value out of the chart. This second box would earn you your answer point. You do not have to do the calculations and get it all the way down to that 8. You can just stop it right here. You can't stop at the step above because when you're asked to evaluate f of certain values, you actually need to pull those values in and then you can quit. Here's an alternate way of evaluating this integral. Instead of using the integral of a constant, I just did the antiderivative of 3 and got this 3x. The antiderivative of 5f prime is 5f of x. And then just plug the 13 and the 2 in. And you would end up at this point right here, which is fine to leave this. If you evaluate that, you would get an 8, but you'd be okay to leave it at that point. There's no right or wrong way. It's just whichever works best for you. Our next question is a left Riemann sum. The left Riemann sum is going to approximate this integral from 2 to 13 of f of x. So I find the difference in my subinterval, which is a 1, and I multiply times the height on the left. So my first rectangle is 1 times 1, and my second one from 3 to 5 is 2 units, times the height on the left would be a 2 times 4. That's my second one. And then this is 3 times negative 2, and my last one is a 5 times 3. Remember, you have to show products and sums, so you want to make sure that whenever you do any of these Riemann sums, you have multiplications shown as well as the addition shown, and that's going to earn you a point. In this particular problem, your final answer earns you a second point. There is no requirement to do these calculations, so if you just stopped with this original pink box right here, you would actually earn both points. If you choose to calculate and you do it wrong, then you sacrifice this point, but if you just leave it up here, you would earn 2 points with that original statement. In part D, I'm given that f prime of 5 equals 3, that f double prime is less than 0, and the next sentence wants me to use the line tangent to the graph of f at x equals 5 to show f of 7 is less than or equal to 4. If I'm going to use the tangent line, the first thing I'm going to do is write what that tangent line is. To write my tangent line equation, I need my point and my slope. F of 5 is negative 2, that's my point. F prime is given as 3, that's my slope. From that, I can write my equation, which is right here. The question also tells me that f double prime is less than 0. What that's telling me about f is that we have a concave down graph. And recall that when you have a concave down shape, as I have here, my tangent line lies above it. So my function value is going to be less than my tangent line value. So when I do my tangent line value, when I take that 7 and I plug it into my tangent line, I get a 4. But since my tangent line is above the graph, my f of x is below. Therefore, f of 7 is going to be less than or equal to that tangent line value of 4. Point-wise, you get a point for this equation, and then you get a point for this justification of why f of 7 has to be less than or equal to 4. The second part of this question wants to use the secant line, so I first need to write the equation of a secant line. A secant line just cuts through that graph in two places. So I just, on my interval from 5 to 8, I pull up my ordered pairs out of my table. And now I write the equation of the line passing through these 2 points. It's actually an Algebra 1 concept. I find my slope, y2 minus y1 over x2 minus x1. There's my slope. And then I use either one of these points. I have both equations written, but you either need this equation here, or you can use this equation here, depending on which of these 2 points you chose to write that equation with. If you look at my graph here, if my secant line is cutting through f of x, you can see that the secant line values are going to be smaller than my f values. My graph here shows me that my f of x values are higher than my secant line values. So when I take my 7 and I plug it into my secant line, it gives me 4/3. Because of the shape of this graph being concave down, that tells me that my f values are going to be higher than my secant line values, and then I just draw my conclusion. Point-wise, if you can write that secant line equation, either one or the other, you get this point. And if you can make this argument here about why f of 7 is greater than or equal to 4/3, you earn this point over here.